Okay, you have a six-sided dice and a coin. This is number 3. What is the probability that you will roll an even number and flip a head on your coin? So, we have a six-sided dice, I'm underlining keywords, and a coin, just two sides. What is the probability that you will roll an even number and flip a head? So this word "and" is critical here. We want both of these things to happen. So we're going to be multiplying when we see that "and" sign because we want to find the part of a part. So we've underlined keywords. We're showing our thinking to calculate the probability here. So I want to have a probability of even number and head. And so theoretically, we're thinking about this now just based on the first two problems here. We want to think about the probability of an even number and multiply it by the probability of getting heads. So that would be probability of an even number is 3 out of 6 because we could get 2, 4, or 6 times 1/2 because there's heads or tails. So theoretically, I can just multiply these and think, okay, it should be 3/12. Now, I could do an outcome chart for this. Showing heads or tails in one side, 2, 3, 4, 5, 6. And we can see there's 12 possible outcomes from this, and we could see 2 of heads, 4 in heads, and 6 in heads. There's 3 out of 12 possible outcomes. That can simplify to 1/4, but I actually really don't like to simplify in situations like these because right now this beautiful number tells us the total possible outcomes, and this tells us the number of successful outcomes. And I think that's a lot more descriptive of an answer than 1/4 because 1/4 might mislead us to think that there's only 4 possible outcomes, and it really doesn't do the answer justice. So I really don't like to simplify. Are these events independent or dependent? Well, does the dice affect the flipping of the coin or vice versa? Not at all. So these are definitely independent events. And we use multiplication because we're finding a part of a part. So the successful outcomes get smaller when you combine, when your requirements get more specific, your requirements for success get more specific. We know when we multiply fractions, the product is going to be smaller as long as both fractions are less than 1. So that makes sense that the probability of getting an even number would have been 6 out of 12 possibilities, but the probability of getting heads and evens would give us only 3 out of 12. So that's number 3.